So hello and welcome everybody. I welcome you in this session. Here we will discuss the lecture number 5th of our chapter Magnetic Effect of Electric Current. So let's begin this lecture without wasting our time. Let's move on to the next slide. Okay, so here we are. Here we will discuss about the electric generator. And in the previous lectures we had seen about electric motors, and you know that the principle of a electric motor works on the principle of magnetic effect of electric current. Okay, so the circuit of a motor is very similar to the circuit of an electric generator. You can see that in the case of a motor we had connected a battery instead of this galvanometer. This is a galvanometer. Okay, this is a what? Galvanometer. But when we discussed motor, then here there had been a battery. So guys, what happens when we provide electricity to the armature? So due to the magnetic effect of electric current, this armature starts to rotate and this axle starts to rotate. So that is the principle of motor. So motor is what? Motor is a device which converts the electrical energy into the mechanical energy. But electric generator is just opposite of a motor. In electrical generator we provide mechanical energy, and then the mechanical energy is converted into the electrical energy. So here it is written that a device that converts mechanical energy into electrical energy is called an electric generator. I hope guys you understand this point. Now electric generators are of two types. So basically there are two types of electrical generator. So we know that there are two types of current. AC current, let me write it here, AC current and DC current. Okay, so the generator which produce AC current are known as AC generators, and the generators which produce DC current known as DC generators. This is as simple. Okay, now guys, let me tell you some basic difference between AC and DC current so that we can understand the difference between AC and DC generators. So let's talk about AC current. So basically AC current is a current which changes or which alternate its directions after a fixed interval. Okay, so we can see that in AC generator the current produced is AC, and AC current is a current which changes its direction. So if I make a graph of AC current, then it will be like this. Okay, so this is time t on x-axis and this is the magnitude of current. Okay, this is what? Magnitude of current. So you can see, let's suppose this is a one rotation. Okay, so in this one rotation the electric current has changed its direction two times. Here it is positive. Okay, this cycle is positive, and this half cycle is negative. So basically guys, you can see clearly that current is changing its direction. Now you can also see that its magnitude is also changed. You can see here it is 0, but it is increasing and after this peak it is again decreasing and again going to 0, then it is again increasing in the previous direction, or you can say in the opposite direction, and then it is again coming to the 0. So what happens? The AC current changes its direction as well as its magnitude. So this is very, very important. Now let's talk about DC current. So DC current is basically a current which doesn't change its direction. And if I draw the graph for DC current, then it will be like this. This is a time t, this is a magnitude, and here you can see the magnitude is fixed as well as the direction is also fixed. Okay, this is positive direction. So I hope guys you might have been able to understand the difference between AC and DC current. And in the upcoming lectures, or you can say in this lecture also, later part, we will discuss AC and DC current, and we will see more information about these two important currents. Now guys, here in this slide we were discussing about the generators. So this is a simple circuit of a generator. So let me introduce you the components of this circuit. So this is, you can see, this is our pole of the magnet. Let me change the pen. Okay, so this is the north pole, and this is your south pole. Okay, now we know that the magnetic field always comes out from the north pole and enters in the south pole. So this is the direction of magnetic field. Now guys, this is the armature. You can see this is our armature, and there are two conductors A to B and this C to D, and this is our axle. Okay, and these are the slip rings. We call it slip ring. Okay, and this is the galvanometer. And one thing is to be known, and that is our brushes. This B1, you can see this B1 and this B2, this B1 and this B2 are the brushes. So basically you can think that these brushes are not actually connected. They are connected but they are not fixed. Okay, this axle and these rings are free to rotate. Although they are touching it, but they are letting it free to rotate. So you have to keep this point in your mind. I hope guys you understand the components of an electric generator. Now let's move on to the next slide and let's talk about the other important things. Okay, so here we are. Here we will discuss about the construction and the working. Okay, we will discuss construction and working of an electric generator. So first of all we will see the construction of a AC generator, and then I will also let you know the construction and working of DC generator. Okay, so let's talk about this AC generator first. So the structure of an electric generator is similar to that of an electric motor. We know already this thing, that the motor, the circuit diagram or the structure of a motor is as similar as to the generator. Okay, but in motor there should have been a battery, but here in this case you can see there is a galvanometer. So that is the difference. In motor we provide electricity and this armature rotates, but in electric generator we will rotate this armature and we will get current, and this galvanometer will show the deflection. Okay, so in case of an electric generator, a rectangular armature is placed within the magnetic field of a permanent magnet. You can see these are the poles of a permanent magnet, and this armature is in the magnetic field of this permanent magnet. Now the armature is attached to wire and is positioned in a way that it can move around an axle. So this armature is in the position that it can move around the axle. Now when the armature moves within the magnetic field, an electric current is induced, and the direction of induced current changes when the armature crosses the halfway mark of its rotation. So guys, let me explain you now the working of this generator. Then you will also understand the meaning of these lines. So basically guys, what happens when we rotate this armature? Let's suppose I'm rotating this armature clockwise in this direction. Okay, in this direction you can see this is clockwise direction. Now when you are rotating it, then this AB conductor would be going upside. It is moving upside like this. Okay, and the magnetic field, or you can say the direction of the magnetic field, is from north to south like this. Okay guys, now let me apply the Fleming right hand rule. Fleming right hand rule. Now you can ask that why we are applying this rule. So the answer is because we are studying EMI, electromagnetic induction. And what is electromagnetic induction? When due to the change in a magnetic field, the current induced. So here, because a current will be inducing, okay, because in generator what happens? We give mechanical energy and it converts into the electrical energy. So that's why this works on the principle of electromagnetic induction. Okay, so that's why in electromagnetic induction we apply this rule, Fleming right hand rule. But in case of motor, you have to be very careful here that in case of motor we apply Fleming left hand rule. Lots of students get confused at this point, so you have to be very careful. Fleming left hand rule, and this works for motor, and Fleming right hand rule works for generator. I hope guys you understand this point. Now I was telling you then this conductor is moving upward and direction of magnetic field is from north to south. Now when we apply Fleming right hand rule, then we have to keep our index finger in the direction of the magnetic field. Okay, like this. Let's suppose this is your index finger and this is showing the direction of the magnetic field. Now guys, you have to keep your thumb in the motion of the conductor. So where is the direction of the motion of the conductor? So as I already told you that this conductor is moving upside. So the direction of the motion of the conductor is upside. Now when you keep your thumb and your index fingers like this, then your middle finger will indicate the direction of A to B. A to B. And this is the direction of induced current. Because we know that if according to the Fleming right hand rule, that if you keep your thumb, your index finger and your middle finger perpendicular to each other, and if the index finger is showing the direction of magnetic field and if your thumb is showing the direction of motion, then your middle finger will show the direction of induced current. So this will be the direction of what? Induced current. So I hope guys this point is clear to you. Okay. After this, because we know that this is in motion, this is going upward and this CD will be going downwards. Okay, this CD will be going downwards. Now, if you apply Fleming right hand rule for this CD, then you will find out then the direction of the current in CD will be from C to D, like this, from C to D. So guys, a current in this circuit will be flowing like this. This is, let's suppose this is the point X and this is the point Y. So this X, the current flowing in this circuit will be from Y to X. Y to X. This is in the first case, and this is very important. You can see that current is from Y to X because here this point, this AB conductor is moving upward, so current is flowing like this, and this CD is going downward, so current here will be flowing like this. And because this CD is connected to this brush B2, then the current here will be like this, and because this AB is connected to this brush B1, then also this will be going like this. Okay. Now guys, let's talk about the second rotation. Okay, because after the half rotation, this AB would have come in the place of this CD. You can understand that because of this rotation, this is moving upward. So after the half rotation, this AB will have come here and this CD will have come here in the place of AB. Now let me change these notations. Okay. Okay guys, so I hope you are understanding, because this is a little bit difficult, but we do not need to be worried. I am here to make you understand each and every point. So what happens guys, when the half rotation completes, then this will become a point AB and this will become a point CD. Okay. So now after the half rotation, this AB is going downwards. This AB is going downwards. So now when you find out the value, or you can say the direction of the electric current, then you will see that it is from B to A. It is from B to A. Okay. And this B to A is connected because this AB would have come here. This was AB. So this AB would have come here. You have to imagine. You have to be, a little bit, you have to be imagining what I am talking about. This AB would have come here. Okay. And this AB is still connected to this. You might be, getting confused at this point, but you do not need to be confused. This AB which was here has come here in the place of CD, and this AB is still connected to this. Okay, this is still connected to this. So now the direction of the electric current will become changed. It will be like this. Similarly, if you find out the direction in CD, then the direction of CD is from D to C. And because this CD was here before, and this CD is connected to this brush. So that's why now the direction has changed and it will become like this. Okay, these are the previous direction and these are the new direction after the half rotation. So you can see that the direction of the current now is from X to Y. X to Y. Okay guys, so you can clearly see that the direction of the currents are changed. So that's why we will call it an electric, you can say electrical AC generator, because the current we are getting is alternative. The directions are changing here. So I hope guys you understand the concept of this electric generator. Now let's move on to the next slide. Let's talk about the other things. Okay, so here we will discuss the DC generator. Here we will be discussing DC generator. So what happens guys, if we want to convert our AC generator into the DC generator, then we have to make a very simple change, and that change is that we have to use these split rings instead of slip rings. These are what? Split rings. You can see these are splitted. So these are the rings which we use in the DC generators. So now guys, let's see that how the direction doesn't get changed in the case of DC generator. Okay, so this is your conductor AB and we will rotate it like this, again clockwise. Okay, this is the direction of magnetic field. Now what happens, this conductor is moving upside. So because this is moving upside and the direction of magnetic field is from north to south, then when you apply the Fleming right hand rule, then you will see that the direction of current is from A to B, like this. Okay, let me change the direction of current. Let me draw this from other pen, otherwise you will get confused. Okay, so this is the direction of electric current. Now this CD is moving downwards. So because this is moving downwards, then the direction of current in this case CD is from C to D. So in the circuit, because this CD is connected from this point, then the direction will be here like this. Let's suppose this is point X, this is point Y, then the direction of the current in the first case will be Y to X. Okay guys, I hope you understand my point. Now after the half rotation, this AB would have come here in the place of CD. So let me again draw the notation. Let me erase the previous notations. Okay. Okay guys. Now you have to imagine that this point AB would have come in the place of this CD, and this CD would have come in the place of AB. So now let me change it. This is your point CB and this is your point AB. Now guys, what happens? This CD is again moving upwards. This CD is moving where? Upwards. So the direction of the current in CD will be like this, and the direction of the current in AB will be like this. Okay, and how we are finding this direction? By the Fleming's right hand rule. So guys, now this point X is still connected to this CD. Okay, in the previous case, when this armature starts to rotate, this was connected with AB, but here it is connected to the CD. So the direction of the current will be like this, and in this AB Now this AB is connected to this Y. So now the direction of the current in the circuit will be like this. So you can see that the direction of the current in the second case, or you can say in the second rotation, second half rotation, the direction is still from Y to X. It is not getting changed. So why the direction has not changed? Because of these split rings. Okay. But if we use slip rings instead of this split ring, then the direction cannot be changed. So I hope guys you understand the difference between the working of an AC and DC generator. So we don't need to do lots of changes, just we have to make one change, and that is we have to use split ring instead of slip rings in the DC generator. Okay guys, I hope you understand this. So now let's move on to the next slide and let's talk about the other things. Okay guys, so here we are. Here we will discuss about the AC and DC current. Although we discussed it from very first time, but basically I just told you the things which is essential for you. Okay, because after that we were about to study AC and DC current, so AC and DC generator. So to understand those generator we should have a basic idea. So that's why I told you the basic points of AC and DC current. But here I will be explaining these things a little bit more deeply. So basically guys, what happens, we know that alternate current in which direction is changed periodically is called alternate current. In India, most of the power station generate alternate current. So most of the equipment works on the AC current. Okay, so you have to be very careful at this point, and you have to remember this, that AC is used widely than DC. Okay, there are lots of appliances which works on AC. So let's talk about some other facts about AC. So the direction of current changes after every 1/100 second in India. The frequency of AC is in India is 50 Hz. So basically guys, what happens, let me draw the diagram of AC. So this is the diagram of AC. Okay, this is your AC current. So you can see that in one rotation this current is changing its direction. This current is changing its direction two times. Okay, in one rotation. So in 50 rotation it will change its direction 100 times. Okay, because in one rotation it is changing its direction two times, and in 50 rotations it will be changing its direction 100 times. We will simply multiply it with 50. Okay, so that's why in 1 second it is completing 50 rotations. So in 50 rotation it is changing its direction 100 times. So we can simply say that in 1 second it is changing its direction 100 times. I hope guys you understand this point. So that's why it is written that the direction of current changes after every 1/100 second in India. Okay, so in 1 second, okay, it is changing its direction 1 by, you can say 100 times. Okay, now guys, what is the frequency? Frequency is 50 Hz. Okay, AC is transmitted up to a long distance without much loss of energy is a advantage of AC over DC. So basically guys, AC can be transmitted on long distance without much loss of energy. Okay, if for an example this is the transmission when you have to transmit AC, and this is a transmission where you have to transmit DC, then the loss will be higher. loss high, but here the loss is less. So that's why this is an advantage of AC over DC. I hope guys you are getting my point. Okay guys, so now let's move on to the next slide. Okay guys, so here in this slide we will discuss some examples of this AC and DC currents. Okay, and we will also see which tool do we use to find out the direction in case of electrical generator. So let's read out this first question. What is the difference between AC and DC current? So this question is asked very frequently. So you have to be very clear at this point. Then AC current simply means that the current in which direction is changed. Okay, the current in which direction is changed. The current which changes its direction after a fixed interval. Okay, and what is DC? Here the direction of the current is constant. Okay guys, now let's talk about the second example. So which rule do we use to find out the direction of current in electrical generator? So this is very simple. So we know that in motor and in generator different rules are applied. Okay, this is solution of the second example and this is solution of the first example. Okay, so in motor what happens? We use Fleming left hand rule. Fleming left hand rule. And in generator we use Fleming right hand rule. Right hand rule. Okay, so I hope guys these things might have been clear to you. This was very important. So now I am ending this lecture. Let's move on, and now I'm ending this lecture. See you in later parts. So bye bye guys.